Good morning, learners. Today we are going to learn about Pandas library. As we know, Pandas is a Python library for performing data analysis. So if you want to perform in-depth analysis, first you should know about preliminary characteristics of the data. What is the variance in the data? What is the spread in the data? What is central tendency of the data? If you can explore that initially, you can make some better assumptions in order to understand which machine learning model to fit to which kind of data. So it offers a number of data exploration, cleaning and transformation operations that are critical in working with data in Python. And Pandas is built on two different libraries, NumPy and Scientific Python. We shortly call it as SciPy. NumPy and Scientific Python, providing easy to use data structures and data manipulation functions with integrated indexing provided. Now, the main data structures Pandas provides are series and data frames. We are going to work with series and data frames. We can understand this in the simpler sense as series as one-dimensional arrays and data frames as two-dimensional or multi-dimensional arrays. Now, what are the important features, key features of Pandas? It helps to generate descriptive statistics on data, and data cleaning can be done using built-in Pandas functions. You have to clean the data before analyzing it. If there are any missing values or duplicate values or redundant values, then it will be very hard to rely on the results which that particular analysis task gives us. Right? It is not quite reliable. The results will not be quite reliable. In such cases, we need to first clean the data so that it doesn't have any missing data or duplicate data. Right? So that data, clean data, if it is analyzed properly, then the results will be reliable. Now, frequent data operations for subsetting, filtering, insertion, deletion, and aggregation of data are also available. And merging multiple data sets using data frames is made possible with Pandas, and working with timestamps and time series data. Generally, whenever some data is captured, the timestamp will be captured. You will not get the time in a readable format, right? Generally, whenever some data is captured, we expect the date and time to be in human understandable form. But this timestamp will have time calculated from 1970 January 1st in milliseconds. So from that time till that particular data point is captured, that milliseconds will be calculated from which we can't interpret anything. But if we are able to convert this timestamp into a valid date and time, then we can make some proper analysis of that data. Right? For that, Pandas allows us to perform the transformations by using some functions related to timestamps and time series data. Now, these are the additional recommended resources that are available. Now, let's start with how to work with Python. Now, in order to, how to work with Pandas. In order to work with Pandas, first you have to import that library into your Jupyter notebook. So you use import pandas and give it an alias short name PD. So import pandas as PD will import the pandas library into your Jupyter notebook. Right? Now let us see about pandas series. Initially, this is the basic data structure we use, which will be used to construct more complex data structures. Say series is a one-dimensional array kind of structure. Now we can use multiple series to form a data frame. Okay. Now, if you want to create a series, you use pd.series method. Series method is available with pandas, and in this you have two arguments, the data argument and the index argument. The data argument will contain all the data values, and the index argument will contain the row values, row indications. Now, when you execute this and print, you can see that Tom here, whatever is given in the index, that is taken as the row name, and corresponding value 100 is taken as this column value. Here we are getting all the names in the index along with their associated data values. That is why we are using here to create a series. It is something like a key value pair. So you are creating a series with data argument and index argument and displaying it. Now, if you want to just display the index values, you can give the series name dot index so that it displays all the index values. Now, if you want to get some values at a particular location, say Nancy and Bob, at an index location, Nancy and Bob, then you can give a series.loc. Series.loc along with the index values will give you that index name and its corresponding index value, data value, right? Now, if you want only the index location, means you don't want the index name, you just want the index location, then you can use iLocation. We'll see that command later. Now, if you want to just get some values at particular index locations, you can use the index locations but enclosed between two square brackets. You can just give the series name and mention the index numbers 4, 3, and 1. Okay, you have to observe this. We are enclosing it within two square brackets, indicating that we want the values, the index and the data values at this index number. Okay, we are referring to a hierarchical kind of index number here. So we are using two brackets and the index numbers so that at the fourth index we have Eric. You can see here we have Eric, and at third index location we have Dan. Even here the index numbers start with 0. That is why the fourth index number, the fourth row is taken for the third index number, and first index number you will get Bob. Now, even if you want to get a data value at a particular index location, then you can use iLocation instead of location. Location will extract the index and the corresponding value, and iLocation will get the value in that particular index location. When you execute this, you can notice that your second value is Nancy and 100. Now, Nancy's corresponding index value 300, that is being displayed here. Now, if you want to see whether a particular index exists in the series, then you can use the clause in. Bob in SCR, you are trying to find out whether this index value exists in the series. So you are using in. We have used this in our previous videos also. Now we execute this and it gives true because Bob exists here in the series. Now just display the series and see what happens when we apply a mathematical operation. SCR raised to the power of 2, or sorry, multiplied by 2. Then how this operation is applied on each of the data values in the series. If it is a numerical value, it is evaluated. If it is a string value, then it will be replicated. So when you execute this command, you can see that 100 becomes 200. FO, because it is a string, it is multiplied 2. It is displayed 2 times. Then 300 becomes 600. BAR, it is replicated again, and 500 becomes 1000. Okay, this is how we can perform mathematical operations using series. Now you can select some index values and apply mathematical operations on it, not only on all the series items. If you want selected items and apply operations on those selected items, you can still do that by using this series. Index values Nancy and Eric, they have to be raised to the power of 2. So what is there in Nancy here? In Nancy we have 300. and in Eric we have 500. Now these both are being raised to the power of 2. Now you can see that square of 300, we got it as sorry, this is our original series, right? Now on this we are applying. So Nancy, it is 300, square of it we get 90,000, and Eric we have 500, and square of it we get 2,50,000. This is how we work with series. Now we combine multiple series in order to make data frames that we'll see in the next session.